Hey guys, what's up everyone? How are you people doing? Hoping that all of you guys are doing good and taking very good care of yourself. Welcome back to today's session, guys. Today we're going to be talking about electricity. This is session number 5, wherein we'll be talking about resistance in parallel connection. So before we get started, let me introduce myself. My name is Anoop and I'm a Master Teacher of Science here at Vedantu. A very warm welcome to all of you guys out there, and once again hoping that all of you guys are doing good and taking good care of yourself. Alright, so people, this is lecture number 5, which means that we've already done 4 lectures. Before this, wherein we've talked about current and potential difference. We've talked about Ohm's law, then resistance and factors affecting resistance, and also resistance in series. Now if you haven't watched all these videos already, please do that so that you are able to understand and keep yourself updated of what is happening in the class. Right, with that said, guys, let us start this session also with a very simple quote, and the quote for today is this: there is no elevator to success, you have to take the stairs. And that is a fact, right? There is no shortcut to success. If you really want to get to where you want to, then you really have to put in the effort as well. It is not going to fall onto your lap. You can't just expect everything to work out. You really have to put in the effort for that. Alright people, with that said, let us get started with today's session, wherein we're going to be talking about resistance in parallel connection. But before that, guys, in the last session, that is resistance in series, I'd given you homework towards the end of the session. First of all, a big round of applause to all those guys who gave the answer. Hats off, people. Well done, keep up the good work. Anyways, this was the question: what is the maximum resistance which can be made by using 5 resistors, each of 1/5 ohms? So you're supposed to find out what is the maximum resistance if there are 5 different resistors. Of each resistor, the value of each resistor is 1/5 ohm. You're supposed to find out what is the maximum resistance offered by that particular circuit. So if you remember the formula, R is R equivalent in a series connection. We're going to assume that it is in series connection, is equal to basically R1 plus R2 plus R3. That is what it is. In this case, it's R4 plus R5 because there are 5 resistors connected. So the value of each resistor is 1/5. So plus 1/5 plus 1/5 plus 1/5 plus 1/5. So it's basically, if you calculate it, you'll get the answer to be 5 divided by 5, which would give you 5 ohms. Simple as that, right? So it's a very simple question. So here are some of the superstars who actually gave the right answer in the comment section below: Shubham, Dr. Miss Harihar, Gautam, Amaya, Kavya, and then we have Kushi, Krishna, Tasmiya, and also Parameshwar. Congratulations, guys. Well done. Keep up the good work. I hope to see more such answers from all of you guys out there. Now again, if you want your name to be here in the next session, please make sure to comment down in the comment section below when the homework is given. Alright, with that said, people, let us get started with today's session, wherein we'll be talking about parallel connection. Now, in the last session, we talked about series connection, wherein one resistor was connected towards the one end of the other resistor was connected to another end of the other resistor, and we saw that the current is basically the same, but then there's a difference in voltage across 2 points in a series connection. What if I were to connect both the ends of the resistors? Something like this. So this kind of connection is what is called as a parallel connection, where both the ends are connected to each other. That is what is called as a parallel connection. Now what we're going to talk about is what is the kind of current flow and what is the kind of potential difference that you see or voltage that you see across 2 points in these kind of these kind of connections. That is what we're going to talk about in today's session. So let's assume this, guys. Let's assume that R1 is resistor 1, R2 is resistor number 2, and you're creating a potential difference by connecting a battery with a voltage V, and the current is flowing through it, which is denoted by I. So we're going to name these 2 points as A and B. So these are the 2 points where 2 resistors are meeting, that is A and B. Now, what we're going to talk about is what is the current flow as well as what is the potential difference across R1 and R2. So let's take R1 first, alright? So to find out what is the potential difference across R1, which I'll assume as V1. So basically I'll assume this as V1. I want to find out what is the potential difference over here. So to find that out, I just have to find out what is the potential at A and what is the potential at B. So if I find out the difference between the potential at A and the potential at B, I'll find out what is V1, which is basically V1 is equal to VA minus VB. Very simple. Potential difference across R1, that is how I'm going to find V1, which is the potential difference across R1, is basically the potential difference at A minus the potential at B. So that's what I'm going to find. Now to find out for R2. The same exact thing, if I want to find out what is the potential across R2, I can take that as V2 instead of V1, I'll take it as V2. And that is also exactly the same thing because it is again connected at those 2 points itself. So V2 also will be equal to VA minus VB because they are again connected to the same ends. I mean, they are both meeting at the same point. So the potential also for the potential difference across R2 would also be the exact same. So that will also be V2 is equal to VA minus VB. So far so good. But the current, guys, let's talk about the current now. That is a potential difference. Great. What about the current? Now here's what happens. As the current passes and reaches this point, what happens is that now the current has 2 paths to take. So what will happen? This current I will get divided as I1 and I2. So it'll get divided. It get divided because it has 2 different paths. It's like, for example, if you have water flowing through a pipe and you have 2 different pipes connected at a joint, what will happen? Water will flow through both the pipes. It will not just take one pipe. No, it will take both the pipes. So in the same way here also current would flow through that is R1, and it will also flow through R2. And after that, what will happen? They will all meet at this point and again become I. They will both join and again it will become I and it will come back into the battery. So here's what happens. Current over here in this particular scenario is going to be I is equal to I1 plus I2. So I is equal to what? I is equal to I1 plus I2. Now, first of all, from this, what you have to understand this, guys. If you talk about the potential difference in a parallel connection is going to be the same. You see this? V1 is equal to V2, which is equal to VA minus VB. Both the cases when we found out the potential difference across R1 and across R2, we found out that it is VA minus VB itself. There is no change in the potential difference. So potential difference in a parallel connection is going to be the same. But then, if you look at the current, like I told you, is taking 2 different paths. So the current would basically get distributed. So there's a difference in current, but the voltage would actually remain the same in a parallel connection. In a parallel connection, the voltage remains same, but the current difference. In a series connection, the current would remain the same, but the voltage would differ across 2 different points. Got it? So here's what I'm gonna do. I'm gonna represent that I is equal to I1 plus I2 because again the current is again meeting over here. So this I is what at this point, what is it? It's basically again it's joining back to form I. So I is equal to I1 plus I2, right? And we have already seen that VA is equal VA and VB is the same. So I'll take it as V is equal to V1 is equal to V2 because the potential across the points are the same. Now, what I'm going to do is that I'm going to apply Ohm's law. Now, what is Ohm's law? V is equal to I into R, right? Now, I want to find out what is I. I want to find out what is the current. So, I is equal to what? V by R. All right. Now, what I'm going to do is that I am going to substitute these values in place of I1 and I2. So what is I1? Basically the current flowing through this. So I1 is what? The resistance is R1 and voltage is V1. So I1 can be represented as what? I1 is equal to V1 divided by R1. Simple. And across R2, what will be the current flowing through it? So I2 is equal to V2 by R2. Right? Because the resistance is R2, the current flowing through is I2, and the voltage or the potential difference across R2 is V2. So I'm going to represent it like that. Now, here's the thing, guys. What I'm going to do is that I am going to make my life a little simpler by basically making an equivalent circuit. Now, what is this equivalent circuit? Instead of having 2 different resistors R1 and R2 with 2 different values, what I'm going to do is that I am going to put one resistance over there. In place of that, I'm going to replace it with one resistance of the same value. So imagine this, guys. Resistor R1 has a value of 2 ohms and resistor R2 has a value of 3 ohms. So that makes it a total of 5 ohms. So instead of having 2 different resistors, I'm going to put one resistor of the value 5 ohms. That's what I'm going to do over here. I'm going to make my life a little simpler, which I'm going to represent it as RE, which is the equivalent circuit. So basically, instead of having all of this different complex resistors, I'm going to make it much more simpler and represent it as RE. Voltage remains the same, current is also the same, just that I'm going to represent it as RE. Now, we've just seen that I is equal to what? V1 by R1 plus V2 by R2, which we've just seen right now. Now, in place of I am going to show it as V1, or we can represent as V by RE. So basically V is nothing but the voltage that is the voltage difference, that is voltage supplied by the battery, or the potential difference by the battery, and RE is nothing but the equivalent resistance. So I'm going to put it as V by RE. Now we have already seen that V is equal to V1 is equal to V2 because the voltage across the 2 points is going to be the same. So I'm going to remove V completely. All right. So because V, I can, in place of V1, I can represent, right? So what I can do is that I can write this equation as V by R equivalent is equal to V by R1 plus V by R2, because it's all the same. So I'm in place of V1 and V2, I'm going to write it as V. So I can remove V off. What I'll be left with is basically 1 by RE is equal to 1 by R1 plus 1 by R2. Now, the thing is this, guys. In a parallel connection, in a parallel circuit, the reciprocal of the equivalent resistance in a parallel connection, the reciprocal, that is 1 by RE that we just saw right now, is equal to the sum of the reciprocal of the individual resistance, that is 1 by R1 plus 1 by R2. Now, in other words, what I'm trying to say is this: if you have two connections like this, if it's connected, two resistors connected in parallel, 1 by R, that is R equivalent, is equal to, in a series connection, 1 by R equivalent is equal to 1 by R1 plus 1 by R2. If in case you have three connections or three different resistors which are connected in parallel, it will be 1 by R1 plus 1 by R2 plus 1 by R3. If in case you have 4, it will become 4, 5, 1 by 1 by R1, 1 by R2, so on till 1 by R5. Now, if in case you have n number of resistors, it will be the exact same: 1 by R1, 1 by R2, 1 by R3, plus, or so on till 1 by Rn. Now, you can write this as R equivalent is equal to R by N, that is the value of the resistance divided by the number of resistors that is connected. So the value of the resistor and the number of resistors that is connected in a parallel connection would give you the equivalent resistance. Now in a series connection, if you guys remember, I told you that R equivalent in a series connection is NR. So the number of resistors into the number of resistance into the value of the resistance. Here it's R by N. This is for series. This is for parallel connection. Alright guys, so that pretty much concludes a little bit about it. So what I'm going to do is quickly take you through what all we have done in today's session. So in parallel combination, resistors or devices are connected one after the other, so they're in parallel with each other. So the ends are basically, both the ends are connected to each other in a parallel circuit. Apart from that, here the current gets distributed, whereas voltage on the other hand remains constant. Current takes two different paths, but the voltage would remain constant. And if you talk about the reciprocal of equivalent resistance, it's nothing but the sum of the reciprocal of the individual resistance. So if you add up the sum of the equivalent resistance, add up the reciprocal of the resistance, you'll find out the equivalent resistance. It's as simple as that. Alright, so that said, now let us do some questions as well. Try to get that get that knowledge running a little. So we'll solve some questions. In the meantime, you guys can also solve it with me. Again, whatever the answer is, put it down in the comment section below and let me know if you have understood the concepts or not. Right? So here's the first question, people. Let me know. The equivalent resistance in a parallel circuit, if n resistors, each of resistance R is given by what? R equivalent is equal to n plus R. R equivalent is equal to NR, R equivalent is equal to N by R, or R equivalent is equal to R by N. I just told you the answer for this question, so I'm pretty sure that you would have given me the right answer. Anyways, the answer for this question is actually option number D, guys, because in a parallel connection, the equivalent resistance is equal to the value of resistor divided by the number of the resistors connected. The value of the resistance divided by the number of resistors would give you the answer. So the answer to this question is option number D, which is R by N. Simple as that. All right. Second question, guys. This is a question that was given in your board exam, CBSE 2014 board exam. It's actually a very straightforward question. The question is this: for the electric circuit given below, calculate the equivalent resistance of the circuit. you have three resistors connected in parallel to each other. One is 30 ohms, the other is 10 ohms, and the other is 5 ohms, and you're applying the potential difference or the voltage of the battery is 6 volt. You're supposed to find out what is the equivalent resistance. Your options are 1 by 3 ohms, 3 kilo ohms, 6 kilo ohms, or 1 by 2 kilo ohms. So these are the options: 30 ohms, 10 ohms, and 5 ohms. So the answer to this question is actually pretty simple. You just have to calculate the equivalent resistance. Again, if you remember the formula, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. In this case, R1's value is 30 ohms, R2's value is 1 by 10 ohms, and R3 is 1 by 5 ohms. Find out the LCM first. So I'll take it as 30 to be the LCM. So into 3 and 5 into 6. So into 6 and into 3. So that'll be what? It'll be 1 plus 3 plus 6. And this is 30, so that's 9 and 10, so 10 divided by 30 gets cancelled, so it'll be 1 by 3. So 1 by R equivalent is equal to 1 by 3. But then when you talk about the equivalent resistance, you just have to reciprocate it. So R equivalent is equal to 3 ohms. So that will be the answer to this question. The answer to this question is actually 3 ohms. So the right answer is actually option number B, which is 3 ohms. It's not kilo ohms, unfortunately. It is not. That's a typo error. But the answer to this question is 3 ohms, guys, because it's not given in kilo ohms. It's given as ohms. So the answer will be 3 ohms. That'll be the answer. Again, you have to reciprocate. Don't just leave it like that, because you found out the reciprocal. You have to find out the reciprocal to find out the equivalent resistance. So you have to when you reciprocate the value, you'll get it as 3 ohms. Alright, guys. Moving on to the next question. This is a question that is from your NCERT, straight from your NCERT. The question is this: a wire of resistance R1 is cut into 5 equal pieces. These 5 pieces of wire are then connected in parallel. If the resultant resistance of this combination be R2, then the ratio of R1 by R2 is what? 1 by 25, 1 by 5, 5 or 25. Now the question might seem like it's like, sir, what is this? But it is actually a pretty simple question. Let me just tell you how it's done. So first of all, the resistance of the wire is R1. Alright, resistance is R1, which they have given. Now, imagine this is a wire. Alright, you're cutting it into 5 equal halves. Alright, 1, 2, 3, 4, and 5. Alright, so you're cutting it into 5 equal halves. They are asking you to find out what would be the resultant resistance if I cut these wires into 5 different parts and connected it parallel one after the other. So first of all, find out what is the resistance of each and every wire. So what will be the value? So if the entire length, if the entire resistance is R1, the resistance of each and every wire will be what? R1 divided by 5, because they are the one wire, the same resistance is connected or divided into 5 different times. So the resistance of the first wire will be R1 by 5, second one will be R1 by 5, R1 by 5, and so on. All of this, the resistance of each and every wire is basically what? It will be R1 divided by 5. That is the resistance of each and every wire. Now, what if I were to connect this in parallel? That is the question. And let's say that in parallel the resistance is R2. So 1 by R2 is equal to 1 by R1, the resistance of each and every wire, that is R1 by 5, plus 1 by R1 by 5, plus 1 by R1 by 5, because they're connected in parallel. So we know the formula for parallel resistance. We saw that 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3, so on and so forth, right? So I'm just gonna, the resistance of each and every wire is R1 by 5. So I'm going to substitute that value in place of R1 and R2 and R5. So till R5. So you get this 1, 2, 3, 4, and 5. Now, just try to simplify this equation. So it will be 5 plus 5 plus 5 plus 5 plus 5 whole divided by R1, and here you have 1 by R2. So if you find out the value, will be R1, if you just take this to the other side, so R1 by R2 is equal to 25. Simple as that, guys. So the answer to this question is actually, so you're supposed to find out what is the value of R1 by R2. So R1 by R2 is basically 25 by 1. So because you're taking this to the other side, so this will go to the side, and this will again, you just take the values to left hand side and the right hand side, so you'll get it as 25 by 1. So the answer to this question would be 25, which is basically the ratio of R1 by R2. I know it seems like a odd question, but it's actually pretty straightforward. You just need to find out what is the resistance of each and every the smaller piece of wire. Once you find that out, put in the equation of finding out the equivalent resistance and parallel connection, you'll get the answer. Simple as that. Alright, with that said, moving on to the next question. Here's another one, guys. Find the equivalent resistance of the circuit shown in the figure. If the resistance of the first resistor is 2 ohms, 4 ohms, and 6 ohms, and the current flowing through is I, and the voltage or potential difference is V, you're supposed to find out what is the equivalent resistance. Once again, the options are 12 ohms, 11 by 12 ohms, 12 by 11 ohms, or 11 ohms. So you know the formula: 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. I always suggest you guys to write down the equations. It'll be much more simpler so that you avoid all kinds of confusion. So you have 2, 4, and 6. Substitute the value. So it'll be 1 by 2 plus 1 by 4 plus 1 by 6. Find out the LCM once again. So 1 by R equivalent. So I'll take 6 to be the, not 6, I'll take it as 12. So 6 into 2, 4, 3, and 2, 6. So that'll be 6 plus 3 plus 2 whole divided by 12. So that's 9 plus 11. So 11 by 12 is 1 by R equivalent. So R equivalent, or basically the equivalent resistance, is equal to 12 by 11. You have to reciprocate it. Don't ever forget this, guys. So it'll be 12 by 11 ohms. So the right answer is option number C, which is 12 by 11. Very straightforward, very simple question. Moving on to the next question, guys. Here is another interesting question. Now this question is actually pretty simple, but then it's actually a little long. There's a lot of calculation involved. So I'll not be able to show the entire calculation. There's a quadratic equation and all that you have to solve. So because there's not enough space, I'll show you till the couple of steps that you can understand. But then I would want you guys to solve this question by yourself. So the question is this: two resistors are connected in series and gives an equivalent resistance of 10 ohms. When connected in parallel, the same resistors, when they're connected in parallel, their equivalent resistance is 2.4 ohms. What is the individual resistance? So that is what they're asking. They're asking you what is the value of R1 and R2. So the options are each are 5 ohms. Option number B is 6 ohms and 4 ohms. Option C is 7 ohms and 4 ohms. And option D is 8 ohms and 2 ohms. The question is actually pretty simple, but then it requires a lot of calculation. So try to understand the question, guys. Two resistors are connected in series. Or in series connection, we have seen that R1 plus R2 is basically the series. So I'll just take it as RS, series connection, to avoid confusion. So the equivalent resistance is 10 ohms. So they've told that R1 plus R2 is equal to 10 ohms. All right. Now, when these things are connected in the same resistors are connected in parallel, the equivalent resistance is 4 ohms. So 1 by R1 plus 1 by R2 is given as RP, which is resistance in parallel. So 1 by R1, so let me just erase that. 1 by R1, yes, 1 second, guys. So 1 by R1 plus 1 by R2 is equal to 2.4 ohms. So that is what they've given. Now you're supposed to find out what is the individual, you're supposed to find out what is the value of R1 and R2. So what I suggest you to do is that take this as equation number 1 and take this as equation number 2. Now, if you look at equation number 2, you can basically write this equation as 1 by R1 plus 1 by R2. So I'll just write on the left hand side, I'll write the values 2.4 ohms. And this is 1 by R2. So you got this 1 by R2, right? So what I can do is that I can write this as R1 into R2 divided by R1 plus R2, just finding basically, again, if you were to say cross multiply it, you'll get R1 into R1 divided by R1 plus R2. So that is what you're going to get. Now, this is equal to 2.4 ohms. Now, what is R1 plus R2? R1 plus R2, we've already found that as 10 ohms because that is the value that you got in series connection. So what I'm going to do, I'm going to substitute the value as R1, R2 divided by 10. So I'll take 10 to the other side. So it'll become, what will you get? You'll be left with R1, R2 is equal to 24 ohms. All right. So you're going to get 24. I'm going to remove the, okay, I'm going to keep it as 24 right now. Now, what you can do is that I can either find the, take this, I can either find the value of R1 or I can find out the value of R2. So I'm going to find out the value of R1. So R1 is equal to what? 24 divided by R2. Simple. So R1 is equal to 24 divided by R2. Now what you do is that substitute this value in the first equation. That is in this equation. In the series equation, substitute this value. So what you can do is basically, again, I'll have to erase the first part off. So I'm going to erase the first part off. There's a lot of, it's actually a pretty straightforward question, but then like I told you, there's a lot of calculation required. So I'm just going to remove all of this and continue with the rest once again, guys. So yes, done, almost done. Yes, done. All right, so you got this. So what I'm going to do, I'm going to substitute this value, that is R1 plus R2 is equal to 10 ohms. This is what is the equation. This is the first equation. So I'm going to substitute the value of, in place of R1, I'm going to put it as 24 divided by R2 plus R2 is equal to 10 ohms. So I'm going to find out, the LCM in this case. So if we find out the LCM, what will you get? So 24 plus R2 square divided by R2 is equal to 10. So you'll get 24 plus R2 square is equal to 10 R2. Now people, solve this equation. You'll get a quadratic equation. So take 10 R2 to the other side. So R2 square minus 10R minus 10R2 is equal to 24. So if you solve this, okay, not is equal to, will be plus 24. All right, so if you solve this equation, guys, you will get two values, and if you solve that equation, you will get the answer to be as 6 ohms and 4 ohms. So that is the answer, guys. That will be the answer to this question. So if you just solve this quadratic equation, so if you want to solve this quadratic equation, it's actually pretty simple. So 6 into 4 is 24 and 6 plus 4 is 10. So if you put in the values, you will get if you solve this quadratic equation, you'll get the answer to be 6 ohms and 4 ohms. I don't think I have to solve that quadratic equation. I'm pretty sure that you guys are capable of doing it. So that is it for today, guys. That pretty much concludes some of very interesting questions all related to resistance in parallel connection. Now I also have a homework for you people. So the homework for today is this, guys. Find the equivalent resistance of two resistors of 10 ohms connected in parallel. So you have two resistors connected in parallel, and each of their resistance is 10 ohms. So you're supposed to find out what is the equivalent resistance. Very simple, straightforward question. Let's see who gives the answer first in the comment section below. Thank you for joining, people. So that is it from my side. Thank you for joining. I hope you guys liked today's session. If you did like it, leave a like and also share this video, spread the word, and also subscribe to the channel so that you're aware of whatever new videos comes out. And if in case you want to reach out to me personally, you can send me an email on anoop.manoharan@vedantu.com. That's my personal email ID. You can send me an email on that. Alright guys, so that's it from my side. Thank you for joining. See you all in the next one. Until the next time, this is Anoop taking a leave for now. Thank you guys. Bye. See you all. Take care.